Before we classify matter, it's a good idea to look at how the universe is classified. First of all, matter is the part of the universe that has mass and volume. The other part of the universe is energy, and this is the part that has the ability to do work or to change matter. Chemistry is the study of matter. This includes the properties of different types of matter and the way matter behaves when influenced by other matter and or energy. We can first break matter down into homogeneous mixtures and heterogeneous mixtures. The third category would be pure substances, which we'll get to in just a minute. Homogeneous means that the mixture is uniform throughout. In other words, it appears to be just one simple thing. If you look at milk or salt water, these are things that appear to be one thing, even though they're actually mixtures. Pure substances, as I mentioned, are also homogeneous, as are solutions. Things that are heterogeneous have non-uniform composition. They contain regions with different properties than other regions. So for instance, if you looked at mint chip ice cream, you would find that some areas might have more chips than others. If you looked at crunchy peanut butter, in some areas of the peanut butter would have more crunch to them than others, larger peanuts, etc. So these would be examples of heterogeneous mixtures. And again, they're sometimes very easy to distinguish. Other times it might be a little bit more difficult. If we do indeed have a mixture of matter, one of the things that a chemist would do then is try to separate that mixture into the individual pure substances that make it up. So pure substances being elements and compounds. This would be done by physical means, and we'll take a look at a few of the different methods of separating mixtures in just a moment. And as I mentioned, once we take those mixtures down to pure substances, we would either have elements or compounds. And if you notice here at the bottom that if we have a compound, we can break that compound down into smaller parts, either elements or smaller compounds, but this would have to involve some type of chemical process, whereas the separation of mixtures into the pure substances that make them up could be done with physical methods. We're going to want to try to get more comfortable or even start to get comfortable identifying the type of mixture different samples of matter can be classified as. So for instance, here are three that we could classify as either a pure substance, a homogeneous mixture, or a heterogeneous mixture. So the first one is gasoline. The second one is a stream with gravel on the bottom. And the third one is copper metal. You may stop and pause the video and take a, think about these on your own, or just continue on. Gasoline is a homogeneous mixture. It actually is not one particular compound. It's actually a mixture of different compounds. Even though you look at gasoline, it looks very uniform, or it should look uniform in composition because it's homogeneous, but it actually is a mixture of different compounds. Stream with gravel on the bottom, a pretty obvious example. If you include the rocks and the water and the smaller pebbles, larger pebbles, there's obviously not a uniform mixture within all those different things. And copper metal, copper is an element, and all elements are pure substances, as are all compounds, as I mentioned. The separation of mixtures usually involves the use of different physical properties of the components that make up that mixture. Some examples that we'll take a look at are distillation, filtration, and chromatography. Here's a picture of a distillation apparatus. You'll notice on the left that we have a mixture of salt and water. So this is a solution, a homogeneous solution. This mixture of salt and water is heated up so that the water part, which has a lower boiling point than the salt part, would change from liquid to a gas. That gas would then, as you can see, go up the tube here, will go down through this condenser tube. The condenser tube would cool that vapor off, the water vapor, and condense it back into liquid here at the end. So thus we would have water over on the right without any of the salt. So the salt, which has a much higher boiling point, would be left over on the left. Here we have the other two techniques that I mentioned in terms of separating the mixture. The one on the left is filtration. This one should be fairly obvious to us. We have a mixture here of a solid and a liquid, and so we would pour that down through the filter paper in the funnel, and of course the solid would get stuck in the filter paper, could not go through, and the liquid would go through, and you would end up separating the mixture that way. Over on the right is something a little more scientific, I guess. Chromatography. Chromatography is based on the attractive forces between the substances in the mixture and a solvent. So in this case, the solvent was water, and the mixture is ink. So you can see that on the left here, you have a piece of paper with the ink spot and the water starting out at the bottom. As the water rises up, the components of the ink are going to get attracted to the water, and they're going to move up the paper. So you can see how it's starting to separate into three different components here. And then as the water gets up toward the top, you can see again that you end up with three different components that make up the black ink. One of the interesting things you can do with chromatography is if we compare the chromatography paper for the black ink with one for blue ink, we can see that the components in the blue ink obviously have that same yellow spot that the black ink had, but the other part of the blue ink, the other component, must be different from the components in the black ink. And finally, in terms of separation, I just wanted to show you one example of how you would take a compound and separate it into the elements that make it up. So this is the electrolysis of water. So you can see that there is a battery at the bottom here that is going to send current into the water through these two electrodes. The electricity is enough to separate the oxygen from the hydrogen in the water molecule. And what you would end up with then is over on this side of the tube, you would end up with the hydrogen gas, so just the element hydrogen. And over on this side of the tube, you would end up with the element oxygen. So again, this would be involve a chemical process separating the hydrogen from the oxygen in water.